The Singleton Design Pattern is a creational design pattern that ensures a class has only one instance throughout the entire lifetime of an application and provides a global access point to that instance. In .NET development, this pattern is particularly useful when managing shared resources that should not be duplicated, such as logging systems, configuration managers, or caching services. The core idea behind Singleton is to restrict object creation so that only one object exists and all parts of the application use that same object. This is achieved by making the constructor of the class private, which prevents other classes from creating new instances using the new keyword. Instead, the class itself controls the instantiation process and exposes a static method or property to return the single instance. This design helps maintain consistency because all consumers interact with the same object, avoiding discrepancies that might arise from multiple instances. In modern .NET applications, especially in ASP.NET Core, the concept of singleton is often implemented through dependency injection containers, where services can be registered as singletons and reused across the application lifecycle. Overall, the singleton pattern is not just about limiting the number of instances but about ensuring controlled access, maintaining a consistent state, and optimizing resource usage in a structured and efficient manner. The singleton pattern is essentially a design solution that answers how to ensure that only one object of a class is created and shared across the application. In typical programming scenarios, developers create multiple instances of a class whenever needed, but in some cases, this can lead to unnecessary duplication, increased memory usage, and inconsistent behavior. Singleton addresses this by creating a single shared instance that is reused wherever required. For example, consider a logging system in a .NET application. If multiple logger objects are created, logs may become inconsistent or scattered. By using a singleton logger, all parts of the application write to the same instance, ensuring uniformity. The pattern works by combining three key elements: a private constructor to prevent external instantiation, a static variable to hold the single instance, and a public static accessor that returns that instance. There are multiple ways to implement singleton, such as eager initialization, lazy initialization, and thread-safe approaches using constructs like lazy in .NET. In modern practices, singleton is often integrated with dependency injection frameworks, making it easier to manage and test. In simple terms, singleton is about controlling object creation and ensuring that a single, shared instance is used consistently across the system. The singleton pattern is best used in scenarios where exactly one instance of a class is required to coordinate actions across an application. In .NET development, one of the most common use cases is logging, where a single logger instance ensures that all messages are handled consistently and efficiently. Another important use case is configuration management, where application settings such as database connection strings or API keys need to be accessed globally without creating multiple copies. Singleton is also widely used in caching mechanisms, where a shared cache instance improves performance by avoiding repeated data retrieval. Additionally, it is useful in managing shared resources like thread pools or service clients that should not be instantiated multiple times due to performance or resource constraints. In ASP.NET Core, singleton services are typically registered using dependency injection, ensuring that one instance is created and reused throughout the application lifecycle. However, singleton should not be used in cases where multiple instances are necessary, such as user-specific data or objects that require frequent state changes. Choosing the right place to use singleton is crucial because improper usage can lead to tightly coupled code and maintenance challenges. Therefore, it is best applied in scenarios involving shared, global, and relatively stateless services. The singleton pattern is used primarily to control object creation and ensure that only one instance of a class exists, which provides several benefits in terms of performance, consistency, and resource management. One of the main reasons for using singleton is memory optimization, as creating multiple instances of certain objects can be expensive and unnecessary. By maintaining a single instance, the application reduces overhead and improves efficiency. Another important reason is to ensure a consistent state across the application. When multiple instances exist, they may hold different data, leading to inconsistencies and unexpected behavior. Singleton eliminates this problem by providing a single source of truth. It also simplifies access to shared resources by offering a global access point, reducing the need to pass objects through multiple layers of the application. In multi-threaded environments, a properly implemented singleton ensures that only one instance is created even when accessed concurrently. In .NET, this is often achieved using thread-safe mechanisms like lazy or through dependency injection. However, the pattern should be used only when there is a clear requirement for a single instance, as overuse can lead to tight coupling and reduced flexibility. Ultimately, Singleton is used to achieve efficiency, consistency, and centralized control in application design. Without the Singleton pattern, classes behave like regular objects, allowing multiple instances to be created freely. While this may be suitable in many cases, it can lead to problems when dealing with shared resources. For example, in a logging system without Singleton, different parts of the application might create separate logger instances, resulting in inconsistent or fragmented logs. Similarly, in configuration management, multiple instances may lead to duplicated data and increased memory usage. This lack of control over object creation can make the system inefficient and harder to maintain. In contrast, using Singleton ensures that only one instance of the class exists and is shared across the entire application. This provides consistency as all components interact with the same object and improves performance by reducing unnecessary object creation. It also simplifies access, as the instance can be retrieved globally without passing it through multiple layers. However, while Singleton solves many problems, it introduces its own challenges, such as tight coupling and difficulty in testing. In modern .NET development, dependency injection is often preferred over manual Singleton implementation because it provides better flexibility and control. The key difference between using and not using Singleton lies in how object creation is managed, with Singleton offering greater control and consistency at the cost of some flexibility. The Singleton pattern works by controlling how and when an object is created, ensuring that only one instance exists and is accessible globally. The process begins by making the class constructor private, which prevents external classes from creating new instances using the new keyword. Next, a static variable is declared within the class to hold the single instance. This variable is shared across all calls to the class, ensuring that the same object is returned every time. A public static method or property is then provided to access this instance. When this accessor is called, it checks whether the instance already exists. If not, it creates one, otherwise it returns the existing instance. In .NET, there are several ways to implement this pattern, including eager initialization, where the instance is created at application startup, and lazy initialization, where the instance is created only when it is first needed. The recommended approach is using lazy, which provides built-in thread safety and efficient initialization. In ASP.NET Core, Singleton is often implemented through dependency injection, where services are registered as singletons and managed automatically by the framework. Overall, the pattern works by combining restricted instantiation, static storage, and controlled access to ensure a single shared instance. The Singleton pattern offers several advantages that make it useful in specific scenarios. One of the primary benefits is memory efficiency, as it ensures that only one instance of a class is created, reducing resource consumption. It also provides a consistent state across the application, since all components use the same instance. Another advantage is the convenience of a global access point, which simplifies the design by eliminating the need to pass objects through multiple layers. Singleton is also beneficial for managing shared resources such as logging, caching, and configuration services. Additionally, modern implementations in .NET can ensure thread safety, making the pattern reliable in multi-threaded environments. However, Singleton also has its disadvantages. It can lead to tight coupling as classes become dependent on a global instance, making the system less flexible. It also makes unit testing more difficult because the global state cannot be easily replaced or mocked. Furthermore, Singleton can introduce hidden dependencies, making the code harder to understand and maintain. It may also violate solid principles, particularly the single responsibility and dependency inversion principles. Overuse of Singleton can turn it into an anti-pattern, where it becomes a centralized global state that negatively impacts scalability and maintainability. Therefore, while Singleton is powerful, it should be used carefully and only when truly necessary. In a real-world .NET application, one of the most common and practical uses of the Singleton pattern is in implementing a logging service. Consider a large ASP.NET Core web application where multiple components such as controllers, services, repositories, and middleware need to log information like errors, warnings, and user activities. If each component creates its own instance of a logger, it can lead to inconsistent logging behavior, increased memory usage, and difficulty in managing log outputs. To solve this problem, the Singleton pattern is used to ensure that only one instance of the logging service exists and is shared across the entire application. In this scenario, a logging service class is created that handles writing logs to a file, database, or external monitoring system. Instead of allowing multiple instances, the service is registered as a singleton in the Dependency Injection container of ASP.NET Core. This ensures that whenever any part of the application requests the logging service, the same instance is provided. This approach guarantees consistency because all logs are handled by a single centralized object, making it easier to track issues and maintain uniform formatting. For example, a developer might create an interface iLogger service and a concrete implementation logger service. Inside the program.cs or startup.cs, the service is registered using services.AddSingleton. Once registered, this single instance is injected into controllers and services wherever logging is required. This eliminates the need to manually create instances and ensures that all parts of the application share the same logging mechanism. From a practical perspective, this design improves performance because the application avoids repeatedly creating logger objects. It also simplifies maintenance, as any changes to logging behavior need to be made in only one place. However, developers must ensure that the Singleton service is thread-safe, as it will be accessed by multiple requests simultaneously in a web application. This example clearly demonstrates how Singleton is used in real-time projects to manage shared resources efficiently. It highlights the importance of centralized control, consistency, and optimized resource usage, which are key benefits of the Singleton pattern in modern .NET development. The Singleton Design Pattern ensures that a class has only one instance and provides a global access point to that instance. It is mainly used when a single object is required to manage shared resources like logging, configuration, or caching. In .NET, Singleton is commonly implemented using Dependency Injection with AddSingleton, which automatically maintains one instance throughout the application lifecycle. The pattern works by using a private constructor, a static instance, and a public access method or property. Singleton is useful because it improves performance by reducing unnecessary object creation, ensures consistent data/state, and provides centralized control. It is widely used in real-time projects like logging services, where all components need to use the same instance. However, it also has some drawbacks. It can lead to tight coupling, make unit testing difficult, and introduce global state issues if overused. Because of this, modern .NET applications often prefer dependency injection instead of manually implementing Singleton.